So we are in our 2022 paper. Here is the first one. Say number 1A is saying state Coulomb's law. So Coulomb's law says that it comes from saying this: force is directly proportional to the product of charges. The force between two charges is directly proportional to the product and inversely proportional to the square of their separation. So it's going to be r squared. This is one way. We now remove this proportional sign. We put an equal, then we multiply by k. All right. So when we say that force between two charges, the force between two charges, okay, or two charged particles, okay, the force that is between two charged particles, okay, is directly proportional to the product of their charges, and inversely proportional to the square of their separation, okay, to the square of their separation, which is the square of the distance between the two guys. And that's it. Now we go to part B. Says, suppose that you have a constant electric field of magnitude blah blah blah. Okay, and what are they wanting? Let's zoom inside, and it is here is E passing through a rectangle blah blah blah. What is the magnitude of the flux through A? So I know that flux is equal to EA cos theta, and I have flux being equal to the charge inside over the permittivity. I can't use this one. This one is for surfaces. It's for Gaussian when we're looking at some shapes and stuff. So here we have this flux through an area. So basically, I just need to know the theta. Theta is the angle between the normal and the electric field. So here, what is the magnitude of electric flux through A? If E is tilted 60 degrees away from the positive Z axis. Okay, so here, let's put them. I'm going to say this is it's a 3D thing. So let me put it here. It's like this. Okay, that's what your 3D looks like. Here you have your Y, here you have your X, and here you have your Z. So this is Y axis, X axis, and this is Z. So now they're saying that the area is lying in the XY plane. So I'm going to say the area is like this. It's in the XY plane. And what is the magnitude of if E is 60 away from the positive Z? So E is going to be here. Let's say it's going to be going 60 away. So this 60 degrees. And they say, what is or shall I say it's up 60 degrees, huh? Shall I say it is up from the Z? This is 60 degrees. So that is your E. Okay, 60 degrees. So my E is going down like that. So it's coming slanted like that, going into the surface, going into like that. So it is going, but at an angle of 60 degrees. Okay, if it was right along Z, then it was going to come straight in and go out like that. But here it is coming at an angle, right? So what am I going to do now? We are supposed to, okay, this is still there. So it is going in your flux. You should show your lines going in like that. So it's like that. They're going in. Here they are going in. So we can see that they are going in. All right. So now what's going to happen is they're saying, what is the angle? Okay. So the angle between the normal is Z. I can say Z is my normal line here. And because I want my area to be at an angle, so my normal line is actually the line Z. And then this guy is 60 degrees to Z, which means he is 60 to the normal. So it's 60 away from the positive. So it's 60 to the normal. So it's going to be cos 60. That's the angle. So anyway, our angle is going to be 60 degrees. So we can say that the flux is equal to, what is E? E is 5.00 newtons per coulomb times, what is the area? Area is 4.00 square meters times cos of 60 degrees. And I'm going to get my flux. All right. And that's going to be it. I'm going to skip this one, and then we'll go and do the next one. So let's just put, what is my cos 60? I think it's half. So it's going to be, let's see what it is. Give me a second to punch in the calculator. It is going to be 5.00 times 4 times cos 60. I will get 10. Okay, so my flux is actually going to be 10. And what is going to be the unit for my flux? The unit is going to be, I have newtons, I have meter squared, I have coulomb, so it'll be Newton times meter squared then per coulomb. That's my unit, and I am done. This is going to be it. See you in the next video when we answer the next one.